you by thesis123.com. I learn and teach online.
Here's the next question, number 29. The value of the integral minus infinity to infinity sine 2 pi t by pi t dt is equal to, we have our four options. Okay, so this integral will take a little bit of work. I'm going to walk you through it. Now, I always like using Laplace transforms as much as possible, since that is quite it's easier to deal with. So here we can use Laplace transforms in solving this. Okay, so we'll go step by step. Now let's consider the integral given to us. 2 times minus infinity to infinity sine 2 pi t by pi t dt. Okay, so let's use Laplace transform here, and let's consider this entire thing is equal to, say, some I. Okay, now look at the portion that is within the integral formula given to us, sine 2 pi t by pi t. Now this is an even function. Now you know sine by itself is an odd function, but here, since it is 2 pi t by pi t, the entire expression is an even function. So the whole thing here is an even function. Okay, so because it is an even function, we can write the integral. Just look at the integral over here. Because it is an even function, we can split the integral from minus infinity to infinity and write it as minus infinity to infinity, and we can write it as 2 times 0 to infinity. This is only because it is an even function. Okay, so we can split it this way. So let's write this now using this explanation. So we will have 2 into 2 times 0 to infinity sine 2 pi t by pi t dt. I hope this makes sense. Now this becomes 4 0 to infinity sine 2 pi t by pi t dt. Let's write this as equation 1. Now we'll take the part that is inside here, apart from the integral, just sine 2 pi t by pi t. Okay, let's take pi outside. That's even better. We'll take pi outside and just consider sine 2 pi t by t. Just consider that part. Sine 2 pi t by t. So we are going to find out the Laplace of this. Okay. Now recall the formula. Laplace of f of t by t is equal to integral s to infinity Laplace of f of t ds. Now this is a formula that we will have to remember. Okay, so keep in mind we are going to use this here. So if you notice, if you compare them to, you will see that f of t by t corresponds to sine 2 pi t by t. So in order to solve this, the Laplace of this is this, integral s to infinity Laplace of f of t, that is Laplace of sine 2 pi t. Let me just take another sheet of paper and we'll continue. Okay. Alright, so now we have Laplace of sine 2 pi t by t. Using the formula, we write it as integral s to infinity Laplace of f of t. So that's sine 2 pi t ds. Okay, so Laplace of sine, we know that s to infinity 2 pi divided by s square plus 2 pi square ds. Now you're quite familiar with this as well, but just in case, let me write that here. Laplace of sine a t is equal to a by s square plus a square. Okay, all right. Next, let's see now what we have. We will have to use another formula. So let me write that formula down as well over here. This is an integration formula. Okay, so we have done this in intermediate, so I want you to just remember that. The integral of a by x square plus a square dx is tan inverse of x by a. Do you remember this? This is what we are going to use here, and it's quite similar. So that's what we are going to use. Okay, so integral of s to infinity 2 pi by s square plus 2 pi whole square ds. We relate it to this formula here, and we can write this as tan inverse of s by 2 pi, and this is from s to infinity. Now if we apply the limits, we get tan inverse of infinity minus tan inverse of s by 2 pi. If we are to solve this, we get pi by 2, that's pi by 2 infinity, minus tan inverse of s by 2 pi. So 90 minus tan inverse theta is cot inverse theta. So please remember that. That would be cot inverse of s by 2 pi. Okay, I'll write that here. 90 minus tan inverse theta is cot inverse theta. All various formulas. Okay, all of these are basics that we have learned during our intermediate. So we have to just incorporate all of that, including with what we have learned in linear algebra during our first year and second year of engineering, and apply all of that to problems like this. Indeed, it is a lot to remember, but with practice you will get it all. So far we have cot inverse of s by 2 pi. Now I think I will just flip this around. I'll work it out over here. So the next step is, I'll just write that down here. We have L of sine 2 pi t by t is equal to cot inverse of s by 2 pi. This is what we have. Now let's substitute s is equal to 0. We'll substitute s is equal to 0. 0 to infinity sine 2 pi t by t dt is equal to, now we are applying the integral. Okay, so integral of this would be cot inverse of 0 when we substitute 0 into this part over here. Now cot inverse of 0 is pi by 2. Let's call this equation 2. So now let's look at what we had at the very beginning. We had, I'm sorry, I just take another color. Okay, 2 integral of minus infinity to infinity sine 2 pi t by pi t dt. This is what we started with, and we came to a point where we had 4 by pi 0 to infinity sine 2 pi t by t dt. Now integral of sine 2 pi t dt is pi by 2, right? That's what we have just worked out. This entire part is pi by 2. So this is I, what we started out with. Yes, okay. So here we have now 4 by pi into pi by 2. 4 by pi into pi by 2, that comes to 4 by 2, which is 2. Well, here is the final answer. The final answer is 2. I'll just note that down here. That's option number D. Well, I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+, and Pinterest.